handout 2 is dealing with slope again, and using the similar triangles that we talked about the other day. So I'm going to use my finger without the pen, so hopefully this works better. So it says Joe and Kelly are each going to find the slope of the graph shown by comparing the ratio, which is just a fraction, of the rise over the run. Remember that, rise over run. Use the graph to answer the questions below. So we got, let's see. In order to find the slope of the graph shown, Joe chose the points 0, 0. So you're going to make a point 0, 0 right there. And mine did not draw in there. So let's see here. And then 2, 4. So you're going to put dots right at those spots. And I can't get mine to work. And then you're, oh, there it goes. And then 2, 4 is right there. And then to make a right triangle. Whoops. Draw this triangle on the graph. Oh my golly. So you can either go down or you can go up. I'm just going to go down and draw my triangle here. And then it says, using Joe's triangle, what is the slope? So make sure you look to see what they're counting by. So they're counting by ones on each side. Oh my golly. I'm having problems. Okay. So what is the slope with Joe's triangle? And I got my cat coming in again. So we go, you can go down or up. So you're going down 4 and over 2. So it would be 4 over 2, which equals 2. So the slope would be 2. And then in order to find the slope of the graph shown, Kelly chooses the points 2, 4 and 5, 0 to make a right triangle. So she's choosing different points. Remember, as long as you find ones that are right on corners, then you're good to go. So go over 2 and up 4. So she's using that same spot right there. And then also she's going over 5. Is that 0? Let's see here. Oh my golly, I am having major difficulties here. So we're trying to see if that is 5, 0. Okay, I guess it is. And so at 5, 0, which doesn't even make sense. All right, so now I can see that it is 5, 10. And so you're going to put a dot right here. And we had one at 2, 4, which is right there. So if we draw the line, we're going from 4 up to 10. So we should have a line all that way up here. So that would be going up 6. And then we're going to go over 3. So that's 6 over 3, which if you notice, it reduces to 2. So how are their triangles related? Well, basically they're similar because they're proportional, because 4 over 2 equals 6 over 3. So they both equal 2. They simplify, so they have the same rate of change or they have the same slope. You can say either one of those. So why is it that we can use any 2 points on a line to find the slope? Pause and think about that for a second. So you should have said something, and you need to write this down, about you can use any 2 points because the line is constant. The slope is constant the whole time. So it doesn't matter which we use. The rise over run is going to be the same regardless because the slant just keeps going at the same rate. Okay, number 7, kind of a tricky one. Based on what you know, which of the following triangles would also lie on the line graphed above? So, the line graphed above, the slope was 2. So you have to figure out which of these triangles has a slope of 2. So go ahead and pause it and see what you come up with. So if you notice here, I wrote the rise over run for each triangle. The rise is the 26, the run is 14. So I did that for each triangle. So to see if it has the same slope as this up here, you just have to divide and see if it equals 2. So once you do that, you'll figure out that triangle B has the same slope. Number 8 is on the back page. So now it says draw 2 different sized triangles that could be used to find the slope on the graph below. And then I want you to label the rise over run. And since it's on the same line, they should have the same slope. So you go ahead and draw those, and we will check those tomorrow. And go ahead and write down the slope. Number 9, which of the following triangles would also lie on a line graphed below? So first of all, and back up here, you make sure you notice that they count by 2s here. Always look for that. So down here, they count by 2s. So first of all, you need to find what the slope is on this line. So I always, if this is right on the corner, I will use this spot right here. And then you need to just keep going until you see one that's right on the corner. And it looks to me like this one is, according to this. So you're going down 2 because they're counting by 2s. So down 2. And then you're going over and they're counting by 1s. So 1, 2, 3, over 3. So you need to find one of these triangles that would have a slope of 2 to 3 that could also be on here. So remember, it's rise over run. So you figure that out and we will check that tomorrow. Number 10, circle the triangle that would not lie on the same line as the others. So again, you need to do rise over run and see which one doesn't have the same ratio. And last but not least, the slope of a line is 1/5. They're telling you the rise is 1, the run is 5. Label the 2 right triangles with dimensions, which is numbers, that would allow the triangle to lie on the same line. So I will give you an example. I know that a triangle with a rise of 2 and a run of 10 would fit on the same line as this. So now you give us 2 more, and we will check that at the beginning of class.